How do we prove that prime numbers are infinite? We're firstly going to start off with an assumption. We know that this assumption is a faulty one, but it's going to lead us to a logical contradiction that's eventually going to prove that prime numbers are indeed infinite. Now, in this assumption, we're going to state that we only have finite prime numbers. And we're going to call these prime numbers P1, P2, all the way up until Pn. Secondly, we're going to construct a new number that's called number n. N is going to be a multiplication of all of the existing prime numbers that we have in our finite prime numbers list. And to that, we're going to add 1. Thirdly, we're going to determine whether n is a prime number or a composite number. Really, for n, these are the only two choices. Say that n is in fact a prime number. If we say that n is a prime number, it's a new prime number that is not in our existing list of finite primes. This, as in of itself, is going to lead to a logical contradiction, as we have found a new prime number that is not in the list of finite prime numbers. If n were to be a composite number, we're going to check its divisibility. This is because if n were to be a composite number, it's going to have to inevitably have prime numbers of some sort. Now, any prime number pi, is capable of dividing a number that's constructed by the multiplication of all prime numbers. However, when we add the number 1 to it, this is inevitably going to yield us a remainder of 1. When we divide a list or a number that's constructed by the multiplication of all prime numbers plus 1 by a prime number. From this, we come to the conclusion that there is no prime number that can divide the number n. And from this, we conclude that n itself is also a prime number. This leads to a contradiction, because we found yet another prime number that's not in the list of prime numbers, and in fact, it's not also a composite number as we have assumed previously. The conclusion that this leads us to is that there are an infinite number of prime numbers. There are infinitely many prime numbers because we've checked that this imaginary number n, if it's going to be a prime number, it's a prime number that's not in the list. That as in of itself is a logical contradiction. If it were to be a composite number, it should be divided by some prime number of a sort, but we know that it's inevitably going to yield a prime remainder of 1. Therefore, there's no prime that's going to be capable of dividing the number n, so n is also a prime number, which is a contradiction to the fact that it's a composite number and also is not in the list of existing prime numbers. And this was Euclid's proof of infinite prime numbers in a nutshell.